Mm. Good evening, everyone present. Today, my colleague Daniela Avalos and I, Ximena Gutierrez, are going to present our thesis on optimization of the supply chain in a SME ice cream distributor using the ABC methodology, economic order quantity, and reorder point. The agenda for today's presentation is divided in 6 parts, starting with introduction and ending with the conclusions and recommendations. The aim of this study was to improve the inventory management and strengthen the company's supply chain through the use of engineering tools. This proposed solution seeks to reduce delayed deliveries and stockouts and offers a cost-effective alternative to ERP systems that are used nowadays in larger companies. And as a result, this solution led to an estimated 3-day improvement in the delivery time for the main customer that is called Cencosud. The image shows the graphical representation of the supply chain, and our improvement proposal is focused specifically on the inventory management section. Regarding the diagnostic stage, we identified that one of the main supply chain indicators, that is the percentage of late deliveries, was above the optimal level for the sector. And these delivery delays were negatively impacting the relationship with the main customer and also over time leading to economic losses. In a similar way, these delays in the inventory management contributed to a high customer service lead time, which is another of our key performance indicators within the supply chain. This analysis revealed that the main issues were deficiencies in demand planning, procurement, and inventory management, and these factors caused frequent stockouts and long purchase lead times, which in turn led to delayed deliveries and extending customer service lead times. As a result, this company faced reduced sales to its primary customer, higher costs from unplanned purchases, and the need of overtime work from the workers. And these efficiencies ultimately generated an estimated annual economic loss of around $20,000. This research was conducted as an applied improvement case study using simulation structure in 4 phases: the diagnostic, the simulation model design, development of implementation manuals, and the impact assessment. For the initial phase, the information was provided by the company, and we use it to analyze the key problems, the root causes and consequences. And also these site visits allow direct observation of product for the production process and the supply chain stages, revealing improvement opportunities. And moreover, also these key performance indicators were collected in order to evaluate a company's performance in specific areas. This is the second stage, the simulated improvement model, and is structured around 3 key tools: ABC methodology, economic order quantity, and reorder point. In the simulation, the first tool implemented was the Q model, which basically prioritizes A category products in each process. And this aims to reduce the customer service lead time and bottlenecks, improving the time-based performance indicators. And additionally, calculating the economic order quantity ensures that the inputs are available before planning the gelato production, and this helps to avoid obsolete inventory by determining the optimal order quantity for each input. And finally, the reorder point concept was applied to determine the optimal timing and frequency for the inventory replenishment.
So now I'm going to explain the results. Basically, we focus on 3 key performance indicators for the simulation. The first one was the customer delivery time, the second, the percentage of late deliveries, and the third one, the percentage of stockouts. So after running the simulation, we observed significant improvements in all 3 indicators, demonstrating the effectiveness of applying engineering tools. As you can see in the table, the average results are the current versus the proposed models. So we can see that in the customer delivery time, there is a reduction from 4.8 days to 2.03. In the percentage of late deliveries, we have a drop from 6.3 to 2.7, and finally the percentage of stocks from 40 to 20. So each indicator represents a significant improvement after utilizing the engineering tools in the simulation. This allows for a reduction in delivery time to the main customer, which is the key indicator for the presented case study. So the income statement, we have also economic analysis, and the income statement reflects an approximate annual savings of 3,500 USD, attributed to various outcomes resulting from the implementation of improvements. So firstly, better efficiency and savings in purchase order have had positive impact on the cost of sales, estimated at around of 1,200 USD annually. Additionally, reducing overtime hours for staff has contributed to a decrease in annual operating expenses by 1,500 USD, and a cash flow analysis was conducted to evaluate the project's profitability. And using a 10% cost of capital, we made a forecast for the next 3 years after the simulation, and we got the following insights in the model. The first one was the NPV was of 7,695, indicating that returns significantly exceed financing cost. The initial investment, as you can see in year 0, is of approx $500. So this indicate that a small investment could have like a high potential saving in the future. And finally, the internal rate of return is like 663. So this analysis confirmed that implementation is not only operationally effective, but also financially sound and sustainable. Discussion. So these researches demonstrate that methodologies such as economic order quantity and ABC analysis are effective tools for managing warehouse inventories, improving production productivity, and reducing bottlenecks in supply chains. In the present study, we observed a reduction in stockout rates and an increase in production output within the same time frame. A key focus was on inventory availability, which was effectively addressed through the application of EUQ in both studies. This study highlights the critical importance of effective inventory management for computer spare parts to avoid both excess stocks and stockouts, which can significantly impact service quality. At Power One Jordan Computer Hardware Software Company, the EOQ model was applied to forecast a 20% increase in demand for specific products. The company achieved a 48% profit margin, indicating a strong performance. However, the study also found that improvements in managing slow-moving items could further reduce inventory-related losses. The authors recommend adopting an enhanced ABC classification model that incorporates the criticality of items, offering a more strategic approach to inventory prioritizations. Conclusion. So the study optimized inventory management for a growing ice cream company by applying ABC classification, economic order quantity, and reorder point strategies. The implementation improved operational efficiency, reduced inventory costs, and shortened lead times. The key outcomes include a reduction in late deliveries to 20%, a decrease in lead time by 2.7 days, and a cost-effective alternative to expensive ERP or IA systems. The model presents a practical and replicable solution for small businesses, addressing a gap in existing literature. Future research could explore the integration of traditional tools with AI to further improve inventory accuracy and support long-term business sustainability. The recommendations. This study highlights that small and medium-sized enterprises in the customer goods sectors can significantly improve inventory management, minimize stockouts, and reduce lead times by applying engineering tools such as ABC classification, EUQ, and reorder point. It recommends future research focus on integrating these traditional tools with emerging technologies like AI and expanding case studies to other industries and regions to validate broaden the model's applicability. Thank you so much.